Thank you very much. Good morning to you all. Very much thankful for the opportunity to share, a little bit of what we have also learned in the last few years with this group. I think it's a wonderful opportunity. So once again, my name is Edward Ofori. Been in the transportation industry for a little over 17 years. Been doing a little bit of everything from roadway design. I spent a lot more time doing ITS and traffic management. But in the last 5 years, I've been doing program management, and that's where the $5.5 billion comes into play, where I'm responsible for overseeing an annual budget of $5.5 million transportation funds for the state of Texas. Very excited to share a few experiences that we have on traffic congestion management, a case for managed lanes in Accra. So, Mr. Moderator, thank you so much for running the slides for me. So I'll go over a few disclaimers first. For starters, the opinions that I'm going to express in this presentation do not necessarily reflect the views of my employer. They are, the content is sourced from publicly available literature as well as a hands-on experience, things that I've experienced myself personally. So I just wanted to put that out there before we get started. Next slide. So this is the overview of the presentation this morning, and I'll try and run through it as quickly as possible and answer any questions that there are. So we'll talk about congestion management and what managed lanes are, the goals and benefits of managed lanes, possibly managed lanes in Ghana or Accra. How does that look like? And I'll make a proposal for what the next steps should be if it's something we're interested in pursuing as a country or as a city. So, congestion management. I know that this term is definitely not new to any of us on this webinar. Having been here in the last few weeks, it's always a concern driving very short distances, but it takes a long time. Congestion causes all kinds of issues for us. Definitely the first and foremost is that there's decrease in productivity of the citizens. We spend so much time on the road in our cars, going to work and coming from work, and those hours could be used in terms of productivity. As congestion increases, we also see an increase in vehicular crashes. It's directly proportional. And then, most importantly, we also have a lot of air quality concerns. As we idle and we run our cars in traffic, we're emitting all kinds of gases that are not necessarily very friendly to the human body. So as time goes on, we develop all kinds of ailments, or the citizens develop all kinds of ailments. So these are the reasons why it's important to mitigate congestion to the extent possible. One thing that we have all universally and globally come to accept is that we cannot any longer build our way out of congestion. It is not anymore possible. We can't continue to expand the roadways. First of all, there's limited right-of-way, so it makes it tough. But then again, even if there is right-of-way, it's very, very expensive to build. And so we need to begin to look at ways where we can improve the current system that we have and make it much more efficient than it currently is to the extent possible. And so here comes, the effective transportation systems management and operations, otherwise known as TISMO. One of my colleagues in the US, I know in the last year or so, also did a presentation on TISMO strategies that are used for congestion management. Typically, these are lower cost measures, but the essence of what we're going to be doing today or talking about today is the focus is on managed lanes. And that is the focus for today. Managed lanes is a form of TISMO, is a form of transportation systems management and operations. So what are managed lanes? These are dedicated and restricted lanes within the right-of-way where all we're doing is we're managing the flow of traffic. We're managing how much traffic gets onto the system, how much traffic gets off the system. And for the purposes of this presentation, as far as managed lanes are concerned, they are done by 3 criteria: vehicle eligibility, access, and then pricing. And we'll take our time to probably talk about all these 3 items and see where things fit in as far as Accra is concerned. So these are my experiences, right? When it comes to vehicle eligibility, you're trying to think about how many people need to be in the vehicle, or how many people need to occupy the vehicle so that they can access those restricted lanes. I have seen, and I have since updated this presentation, but I have seen cases where 2 people in a vehicle qualifies to use it. I've seen cases where 3 people in a vehicle qualifies to use it. And very, very recently, in the last few years, there's an exploration in California where they are going to allow a vehicle that has 7 people, 7 plus. So there's HOV 2 plus, HOV 3 plus, and then HOV 7 plus, which is being explored. There's also the instance of registered van pools or employer transit buses. The essence of all of this is that we're trying to increase the person throughput, meaning the number of people we're able to use to move through the system from point A to point B. So that's vehicle occupancy. And then you also have motorcycles, bicycles, public transport. Those are also given preferential treatment on these managed lanes. Now, the question in Ghana definitely is, are we going to allow the Okadas to also use it? Because I'm sure everybody on this call understands and appreciates that they're a little bit of a nuisance on the roadways. They cause all kinds of issues. And then the third, eligibility criteria is special cases, presidential motorcades, emergency vehicles, police, and fire, allowing them to access these managed lanes so they can get to their destination in good time. So still going back to what managed lanes are, the second criteria is access. How do you provide access to vehicles? There are two ways this is done. Lane separation, meaning that you can just pretty much just stripe or put pavement markings to differentiate between the general purpose lanes and then the managed lanes. So that's an option. And then you can also use concrete barriers, or there's limited access, which means that you only allow vehicles to access it at certain strategic points. That is found to be very, very effective. I've seen instances where we have allowed continuous access, meaning that throughout the corridor, you can access the lanes at any point in time. Of course, everybody can appreciate that these are pretty problematic because there's a lot of weaving in and out of those lanes. And then the third instance, which is actually an expensive one, is a grade separation, where you separate the managed lanes from the general purpose lanes. But then again, that means you're going to put a lot of concrete, a lot of asphalt, a lot of columns and things like that. So that's an expensive version. It's typically, I've seen it used very, very sparingly. But what I've seen used most is the limited access. And then the continuous access has also been used in certain places, all to a reasonable amount of success, right? There are merits and demerits of all these methods. So that's on access. Now, and then pricing. So pricing is the third criteria. I've talked about, the high occupancy vehicle lanes where you allow 2 people, you allow 3 people, you allow, 7 people, whatever the criteria is set by the operating agency. That's high occupancy vehicle lanes, right? And then the next option, price managed lanes, where what you're doing is you are allowing people to use the lanes and pay a fee for it. And so if you say restrict the lanes to, let's say 3 plus, some people are not able to form the 3-person a car. And so therefore they want to still be able to use the lane. So there's only 1 person in the car, but they want to use the lanes. And so you allow them to pay a fee to use those express lanes. So those are the price, or what they call the hot lanes in some places. So some places they call them hot lanes. Some places they call them express lanes. They've actually also been known as Lexus lanes, meaning it's only for rich people. But all it is that you're allowing that excess capacity. If you restrict the vehicle occupancy, you're allowing the excess capacity to be used for a fee. And then, of course, that money can be used for different operational improvements of the corridor. So I've seen it done in all these ways. The goals and benefits are actually numerous. First of all, you're mitigating congestion, which is a big deal. As long as we can increase the vehicle throughput, that is always going to be a great thing. We talked about the benefits already, citizen productivity, air quality, crashes. You're minimizing all of those, so that definitely is a huge benefit. You increase vehicle occupancy. So when you institute managed lanes, what you do is you force people to carpool. Right now, as it is, a lot of people will probably want to ride in their cars by themselves and go to work. But if they can use the managed lanes, then they can pair up. They live in the same neighborhood. They can pick up each other and save gas, save money and all of that. So person throughput is also an increase, especially when we allow buses to use the managed lanes. Most importantly, what I've learned over the years is reliable travel time. The fact that that you can get to your destination in a reasonable amount of predictability, right? If you're going to use the managed lanes and it will tell you exactly how long you're able to get from point A to point B. So definitely that's an improvement. It also helps with incident management response times. The emergency vehicles are able to use the managed lanes and get to where the incident is, and able to, whether it's a tow truck, whether it's a fire truck, whether it's a police, help to relieve that incident, and therefore improve the flow in the general purpose lanes as well. So that's definitely a plus. And then the last two, if we institute the price managed lanes, we generate some money for infrastructure improvement. So if people pay a premium to be able to use the lanes, some money can be generated, and that money can be used for purposes of operational improvements and also for purposes of capacity improvements in other locations as well. I mean, it all depends on how the operating agency wants to institute it. So what I did is very, very high level, take a look at a very recent project. I was able to get my hands on a few sheets of the plans. So look at this Accra Kumasi approach of the Pokwase interchange. And I'm calling it, for the purposes of the presentation, I'm calling it NX. Look at this roadway and see, assuming that we were going to institute managed lanes on this roadway, how would we do it? How would we do it? Now, I want to preface it by saying this is purely theoretical. There is a lot more that is going to go into it. I mean, you don't just institute the lanes just like that. And I'll talk about that briefly. There's a lot of thought process that goes into it. There's a lot of planning and analysis that allows it to be possible, feasible, or otherwise. Because the last thing you want to do is to institute managed lanes that will fail. That leaves a bitter taste in everybody's mouth. So I'll go through the next few slides to talk about, assuming we were going to do this, how would it look like? So first and foremost, when from my experience, when you're instituting managed lanes, you don't go through the typical project development path. It doesn't work. You go through what I have called personally, that's my personal term, the dreaded V diagram. It's dreaded because it's just too complex. It's a lot of things. It's very detailed. It goes through a lot of iterations, and not everybody is very comfortable with it. I mean, but there are certain aspects of the V diagram that are nice, and I'll just talk about those nice parts here. But if we wanted to do a typical managed lanes development, we have to go through this dreaded V diagram using systems engineering analysis, starting from the ITS architecture from the beginning, looking at, the concept exploration, the concept of operations, the system requirements, what it's going to require to operate it, and then you get into the design, you get into software and testing and verification. I mean, there's so many steps that you go through before you validate the system, and then you get into operations and maintenance, which is where most of the projects that I was involved in get to. It's a laborious process. It's a very detailed process. It takes time, it takes effort, it takes a lot of expertise to do it. But eventually, it gives you a reasonable assurance that the managed lanes will be successful, which is what we want, because we don't want to implement something that will fail. Next slide, please. So let's talk about what the concept of operations are, or otherwise known as the ConOps. And I'm sure many of us on this call are familiar with it. So the ConOps answers a lot of basic questions, but I want to highlight just these few ones. So to implement the managed lanes, we need to look at who are the stakeholders for this infrastructure. Who are the stakeholders? Is it Ghana Highway Authority? Is it Department of Urban Roads? Which Ministry of Transport? Who are the stakeholders? You identify what the stakeholders are, and then you go into what the system capabilities need to be. Should the system have, what kind of infrastructure is needed for the system to be able to operate successfully. And then you look at, of course, the geography and the physical extent of the system. If you're doing it within an already established roadway. Now, the example that I gave with Bokwase, it's a brand new roadway, and so you can implement and do a lot of things. But what if you are implementing it, say, on the N1, which is already established, and you're trying to, and by the way, you can do managed lanes from start, or you can do it on an already existing infrastructure. As a matter of fact, most of the projects that I was involved in had an already existing infrastructure where we carve out a few lanes purposely for to manage them. And so you can do it on both, but then you have to look at that. What is the sequence of activities that will be performed? What are we looking at as far as, the concept of operations? How are we conceptually, going to operate the system? What is going to take precedence over what? And then, what really is a problem we're trying to address? Now, the general problem could be congestion, but there could be secondary issues like crashes. There could be secondary issues like there could be all kinds of issues that we'll try to address with this new system, right? And so you want to answer all those questions. And how would it be developed? How would it be operated? How would it be maintained? Of course, last week I joined this webinar, and there was a lot of talk about operations and maintenance, specifically maintenance. So you need to detail all that in your concept of operations before you even get started. So you've identified all these items and all these elements, and you are sure that you have them, in a reasonable place where they're going to succeed, and then you can proceed with your development. Next slide, please. And so this is the sequence of operations for NX. So you look at the existing characteristics of the roadway and what the conditioner is. You look at the different alternative concepts for congestion mitigation, one of which, of course, definitely needs to include managed lanes. And then you look at the design. How are you going to treat access? How are you going to have separation treatment? Are you going to use pavement markings? Are you going to use pylons, barriers, or what are you going to be using? And then very, very importantly, how are you going to enforce the lanes? Because you and I know that it doesn't matter what you sign it to be. It doesn't matter what you tell people it is. There are always going to be violations. There are always going to be people who are just one person in the car and using the lane if it's signed for 3 people. We've seen it several times. I've seen it in excess of 25% violation rate in some places, and in other places 40%, meaning that people cheat the system, which is a human characteristic. It doesn't matter, people are going to use it. So how are you going to enforce these lanes? So in recent managed lanes developments that I was part of, we created enforcement zones, which allows the police to park their car there and be able to easily access the lanes and pull people over and give them citations for not using for not having the right occupancy and using the lanes. And then you talk about the roles and responsibilities of the different stakeholders. You know, like I mentioned, is it highway authority? Is it urban roads? Is it the Ghana Police Service? What is each stakeholder's responsibility? You outline that very clearly in the concept of operations. And then you decide how you're going to operate the system. Is it going to be a part-time managed lanes, meaning that you're going to allow it to be restricted for certain parts of the day? For instance, typically like rush hour from 6 a.m. to 9 a.m. and then maybe from 3 p.m. to 6 p.m. Or are you going to allow it to be a full-time managed lane? Now, where I've seen this to be very, very effective is when it's part-time, especially if you can correctly identify the peak hours, that the peak commute times. The part-time works really, really well. And then you also you decide on what the vehicle eligibility is going to be. Of course, this has to be based on data. This has to be not just based on the whims and caprices of whoever the project manager is. The data should suggest that you will be able to easily form three-person carpools or 7-person carpools or whatever the case may be. And then you know, very importantly, address environmental justice issues. If there are equity issues, for instance, if you are going to price the lanes, it means that you are isolating some people who may not be able to pay. So how do you mitigate against such situations? So the natural environment and the human environment, we want to make sure that any kind of environmental justice issues are addressed. And then I talked about enforcement and incident management, to have response plans if something happens in those lanes, because the last thing you want is an incident on the managed lanes and it's completely clogged, and then the general purpose lanes is actually moving faster than the managed lanes. That will be a complete failure. And then lastly, what are the performance measures that you're going to use to assess whether the lanes are succeeding or whether they are failing? You know, speed, travel time, and other metrics that you can use to assess the system. And then we go on to, you know, who will use it, you know, the design considerations, because all of these are going to influence how the lanes look like. Who will use the lanes? What is the vehicle mix? Is it a lot of trotros in that area? Is it a lot of buses? Is it a lot of commutes to the central business district? Meaning that you can probably use employer-provided transit systems. And of course, the dreaded Okadas, who are problematic, as we have all seen and observed. And then you look at the geometric design considerations. What are, you know, the typical roads, cross sections, the lane widths, the shoulder widths, enforcement zones, if any, and then what kind of design speed do you want on those managed lanes for it to be completely effective? So here I have, you know, recommended cross sections for HOV lanes, assuming you're going to institute that. And these are just recommended sections. So the minimum sections you can have. Pardon me, I have since forgotten my meters and stuff like, so I deal with the feet. So 12-foot lanes. If you have 12-foot lanes with concrete barriers in the middle with, you know, adequate shoulder, about 4 feet shoulders. You can also have 2-foot shoulders, you know, with 12-foot lanes for the managed lanes, or you can actually have a big old wide shoulder in excess of 10 feet and still have, you know, your 12-foot lanes. The essence is that you want to make sure that you're providing some reasonable space on the shoulders. Then again, I preface it to say that I've seen it where we have basically the lanes button up against the concrete barriers, which is not a very safe maneuver, but you know, sometimes you have geometric constraints, site constraints, and you do it only for a short time, for a short length, so that you increase crashes even with that. So I took the liberty, once again, from a very theoretical standpoint, looking at the cross section for the Pokwase, the approach on the Pokwase roadway, and look at, assuming we were going to implement managed lanes here, we have a big old median, which is in excess of 10 feet, right? It's a huge median, but you can have your 12-foot lanes, or I think it's 3.55 meters of HOV lanes, right button up against the median, bi-directional. I've seen it in maybe a topic for another day, where you can actually reverse these lanes, you know, depending on the direction of traffic. But anyway, just to give you a little flavor of how it would look like, assuming it was being implemented on this hypothetical NX roadway. So you have the HOV lanes or HOT lanes. Now, when it comes to the hot lanes, there's a lot more infrastructure that comes with it, because you have to implement, the toll gantries. You have to put the toll gantries, the cameras, and things like that. HOV lanes have reasonable equipment that you institute there. You still need some cameras, you still need your radars for speed detection and things like that. But there's a lot more extensive when you go to the hot lanes or the high occupancy toll lanes. And then you look at the operational policies for this NX. Is it going to be a part-time managed lane feature? Is it going to be a full-time? And if it's part-time, what are the peak hours? Personally, that's just my personal preference. I've really liked the part-time ones because you allow that. Sometimes it's not always that you can build that high occupancy vehicles during the day. Now, if we were going to use it just for buses or just for just for buses or transit buses, maybe you can have it throughout the day. But depending on what the characteristics and the commute patterns in the area are, maybe part-time use could give you optimum efficiency. And then, vehicle eligibility, are we doing HOV 2+? Are we doing 3+? Are we doing 7+? Are we doing emergency vehicles and buses? And then where are the ingress and egress locations? How do you transition? Which is really, really problematic. I've seen it where most of the problems are caused at the exit and entrance points. How you transition from the general purpose lanes to those managed lanes. If you don't design those very well, those become the choke points, and you definitely don't want that. And then signage and pavement markings, absolutely, positively very necessary. You want to make sure that you're signing this very clearly so that the commuter or the driver can understand what it means. We don't want to confuse anybody with the signage. We don't want to confuse anybody with the pavement markings. And what is going to be the enforcement strategy? How are we going to be finding people who violate this? Now, like I mentioned before, don't feel bad because people are always going to violate it. I've seen it in excess of 40%. And they have made the calculation, maybe rightfully so, that every police vehicle can only pull one person at a time. And so I'm going to keep on cheating until I'm caught. And then if I'm caught, maybe the fine will be equal to what I would have paid if I had used the hot lane. So, you're going to have that. And I presume, and I know for a fact that that's going to definitely happen in Accra if we try to institute it here. And then you cannot implement these managed lanes in isolation. You have to look at how it coordinates with the other roadways. How does it, coordinate with the other roadways? Other than that, it's going to be a failure. So I talked about how you design the entrance and the exits points. So you definitely need to look at that in your operational policy development. Now, let me talk very briefly about the critical issues that you are going to definitely experience if you go through this. Now, this is not a silver bullet. This is not going to solve all the problems. So I want to make sure that I preface by saying that because several managed lanes have failed. They have not been able to meet their performance metrics. What they have not failed with, which is why I talked about it earlier, is the travel time reliability. If there's one thing that has been a positive with managed lanes, it is that you will be able to correctly and accurately predict your travel time. It's worked, in one, plus or minus a minute or two, but it's worked very, very well as far as travel time reliability. But implementing managed lanes is very, very complex. It is a very, very, very complex endeavor. And that's why you go through the detailed V diagram to be able to ensure that you will be able to succeed, because it's not something that you just wake up and slap it on the roadway. There's a huge issue with public acceptance. So think about it. You have 3 lanes that is already congested, and you're going to carve 1 lane and use it for special people, which is how the public is going to see it. So how you go about with, your public engagement is very, very critical. If the implementation is going to succeed or fail, it depends on how well you do your public involvement strategy. Because public acceptance is huge, especially if you ask people to pay to use the lanes. Nobody wants to pay. Whenever I'm driving, I always set my GPS to avoid toll lanes because I don't want to pay. It may take me a little longer time, but I don't pay. But of course, if I have to get there within a certain time, once again, going back to travel time reliability, then I'll pay and do it. But if I don't have to, I'll try and leave home as early as possible so I can avoid it. So public acceptance is huge, especially if you're going to ask people to pay. And then there are several operational issues that it brings about as well. There are weaving concerns at the entrance and the exit points. How people get in and out of the lanes is a concern. If you don't design it very well, that could become your bottleneck, and then it could actually derail the system. Traffic incident management sometimes could be a concern if you don't have adequate shoulder width to be able to move a stalled vehicle out of the lanes to continue to flow the lanes. That could be an issue. Enforcement of violations, I cannot overemphasize it. It's a huge issue. Wherever I've seen, there's video technology that is being developed to be able to use that for enforcement, but it's not even ready to be fully implemented yet because it is not 100% accurate. You want to get to a reasonable amount of accuracy before you even implement it. Then there's traffic performance, speed, travel times, vehicle throughput. This picture on the right side is on the entire managed lane system in California. And they have 1,778 lane miles of HOV statewide. And out of this, you have, they call it degraded lanes, meaning that the lanes are not meeting their performance metrics. And this graph shows you that 53% of the lanes that they have are not meeting their performance metrics. And the performance metrics are that they want the lanes to travel at a minimum of 45 miles per hour. So if they are traveling averagely less than 45 miles per hour, they call them degraded lanes. So 53% of them are not meeting that performance metrics. 21% of them are meeting the performance metrics. And then, about 26% of them, the data is not conclusive for one reason or another. So I'm sure that even if the data was completely accurate, the 53% will be a lot higher than that. The performance metrics is a huge, especially when it comes to speed, is a huge metric to meet. And that is why, the literature is shifting towards reliability, because reliability is the one that that, 9 times out of 10, you'll be able to meet those metrics. So traffic performance in the general lanes is a huge issue. So if you have traffic performance in the general lanes that are not working well, then people will violate to use the managed lanes, and it defeats the purpose for which you establish those managed lanes. So this slide is just to say that there are critical issues even with managed lanes. It is not a silver bullet, but it's a pretty good system. It's a pretty good implementation that if it is done well, it can really, really solve some of the challenges that you have with congestion. So what are the next steps? If this were going to be instituted or this were going to be looked into, what are the next steps? One of the first things that needs to happen is we need volunteers. We're going to need a lot of volunteers, and I volunteer myself to be a part of any kind of study that will be done with this. I've had some pretty extensive experience working on different kinds of managed lanes projects, but a detailed feasibility study and analysis is needed. Before you even begin to implement it, you have to establish what a governing policy looks like. You have to establish what a managed lanes guidelines looks like, including operational standards. You have to establish a methodology to determine if managed lanes are even feasible. And then you also have to determine a methodology to do a cost-benefit analysis, because we don't want to spend money to implement something that costs us more than it benefits us. And so you have to go through all of this. And once you have established it and you have a clear-cut policy, I think you can begin to look at the entire system in Accra and identify candidates that, roadway candidates that you can implement this system on. I believe that when this is done, Some of the congestion, not all of it, but some of the congestion will be mitigated, and it will be very, very effective. It'll make a lot of people happy, especially the buses, the transit, the emergency vehicles, the police service, and others. So that's the end of my presentation. I don't think I have. I have a few references that you can always look at.
Thank you very much.